Hello community, so great that you are back. Today we code LLMs for advanced O1 reasoning. And we want to spend less than $500 or 500 euros for this. And you notice, no? We have these super powerful LLMs like OpenAI O1, or QWQ, the Gemini thinking model, the DeepSeek R1, and they all run this advanced inference reasoning here, where they think multiple minutes here in the inference run. And then on the other side, we have all the other poor little LLMs that are not as powerful. And today we help those LLMs. Maybe you have an LLM that you want to empower here with the O1 reasoning patterns. So let's help those little LLMs to come up almost to the level of an O1 reasoning. And it all starts with my video of yesterday, where I showed you here an implementation here by Harvard University and Microsoft R* mathematics, how we can code here this thinking 2 method here, chain of thought, on a small language model. And I got a beautiful reply and say, hey, it's not particularly accessible for most practitioners. And I thought, I accept this challenge. So today I'll show you how you can bring this into your life. You remember yesterday? No, Microsoft was talking here with DeepSeek Coder version 2 and then the Q1 2.5 Math 7B model. So interestingly, Microsoft itself used here models from our Chinese colleagues and not here from OpenAI or Microsoft itself. And we need, first step, of course, we need some computation, cloud performance. Let's go with Lambda. Unfortunately, not sponsored at all. And then I need some help from our friends at UC Berkeley, the Sky Computing Lab. And if you don't know them, you know DSPi? Yes, now this is the team that we are looking, and we need their help to come up with this implementation. Now, okay, I have to show you another AI research report. This is here from the 22nd of December 2024. And this is here what we call STILL2. So what is STILL? STILL stands simply for slow thinking with LLMs. This is this phase 2 thinking, this inference run, this test time computation here, where you have in your inference run multiple minutes of time. And if you want to have here the complete code, this is the code to the GitHub. Great. Now, they explain in this paper everything they do, but since you have seen my last video, you know all of this. And yes, they looked here because O1 does not give us here the single reasoning step. So here you have the single reasoning step by QWQ and by DeepSeek. So you see exactly how they are approaching the problem, what is the reasoning pattern that they apply. And yes, since they are open source, they are transparent. And yes, we can use them to understand here the reasoning process that's happening in those LLMs. And here we go here with this paper of STILL2, and they say, hey, after collecting now the instruction data from our very powerful Chinese colleagues for the long form reasoning and the long-term reasoning, this phase 2 reasoning, they say, hey, we simply fine-tune here another model to replicate the behavior of this slow thinking system 2 mode. So the easiest approach you can think of, we just need the training data for these long-form reasoning patterns, and then we just fine-tune here a simple LLM that is not enabled with this chain of thought inference, and we want to replicate now the behavior with this slow thinking mode. And what we do, we optimize the model using here the classical Huggingface supervised fine-tuning methodology. Now, STILL2 interestingly went here with a Q1 2.5 32B instruct model as their model to be fine-tuned here on this particular long-form and long-term reasoning chain of thought, for example. And they give us here really everything. They give us here the prompt template for the reasoning model. You can go there, you can read this in detail, and you understand what is happening. And they progressively refine now their training data set. And you can do this, you remember, you can incorporate more correct trajectory of the reasoning by more challenging problems, or you can refine this by adding more high-quality trajectories that are generated here by an improved, more powerful reasoning model. wherever you go, you can now progressively improve the performance given new high complex training data. And either you can go with a supervised fine-tuning or in the paper of Still 2, they go here with a DPO reinforcement learning for particular paired positive and negative instances. And yeah, this is exactly what we went through in the video yesterday, what Microsoft also did. So beautiful. And here we have now another topic you should be aware of, the data. They say, hey, we had really to take special care about the data mixture. And they prepare a particular mixture of the training data, and they have 3 components. They have the real hard mathematical problems, then what they call the normal mathematical problems, and then some simple data from other domains. And the conclusion is the ability to perform this long-term thinking, example, this chain of thought inference reasoning, can be effectively elicited by training with a small amount of really high-quality demonstration data. So great, we have our LLM as a pattern generation engine now, and we utilize this to have our smaller LLMs also with this O1 reasoning capabilities. But since we cannot take it from O1, we go to the open source model from our Chinese colleague. And all these distillation-based variants perform acceptable. So you see, if you go there today, I think this is really interesting, they already have now the next step. They go now with visual reasoning with long thoughts. They call this Virgo. And here you have the GitHub. And if you're really interested, here this is the paper Virgo, a preliminary exploration on reproducing O-like-M LLMs. Really interesting, 3rd of January 2025. So there's a lot of new knowledge out there. And since the topic we're going to talk today, Sky-T1, was done with the support of Anyscale, so whenever here companies here help the open source community to advance knowledge and make new open source model available, I will mention them. So here, although not sponsored, unfortunately, Anyscale, have a look at those companies. But now let's really see what UC Berkeley did. And you know, the beauty is they open sourced everything. You have the complete access to all the models, the code, the complete training data, and even their training scripts and everything. So if you want to go here for a real open source, I would say, hey, SkyThought, this is it. Yeah, you go on Huggingface, and I already prefer if it is available on Huggingface, and here you have now NovaSky. So you have here the NovaSky AI, the SkyThought 1 model. It's a 30 billion preview model, updated a day ago, and this is exactly it. And for the dataset, you also 13 hours ago, here you have it on Huggingface. This is their training dataset. So the training dataset is available for you to download, and it is rather small with less than 300 MB. Great. Now, if you want to have here the complete code and everything, go here to this GitHub repo, SkyThought. As you see, the data just updated 23 minutes ago. So enjoy this, and they have here the Sky-T1 model. I think this is really the first of this idea, but imagine you can train your own LLM with a performance that is close to an OpenAI O1 preview model with about $500. So really impressive. And license was included 3 hours ago. We have an Apache 2 license, so open source for your activity. Really nice, UC Berkeley. Thank you. Now let's have a look at the models that they used. Because if we talk about distillation and improvement in the reasoning, we have to start somewhere, no? So they say here to generate here our training data, UC Berkeley is talking, we use here the QWQ32B preview model. This is an open source model here with reasoning capabilities comparable to the O1 preview model by OpenAI. But as I've shown you here in this video, they give us the exact reasoning step by step. And then we used our training data to fine-tune another model. This is the QWEN 2.532B instruct model. However, please notice this is an open source model without the long form, for example, chain of thought reasoning capabilities. So what we do now, we take here a model that has not these reasoning capabilities like O1, and we train it here on a training data set that we received from an O1 competitor that is even having here the same performance like O1, and it is open source. So open source is really winning here. And then this model is trained here for 3 epochs and the learning rate, and they give you everything, and they tell you, hey, we spent 19 hours here on the platform I just showed you, Lambda, that we use there, the 8H100 GPUs here, and with the pricing they paid $450. Great. So you can see with this code that is open source, it's available for you. You can now train your LLM that you prefer with a much better reasoning ability here for some long form and long-term reasoning, because we have the training data. But you know what? It is interesting here. This open world is really fascinating sometimes, because think about it. We have UC Berkeley. I mean, one of those other institutions in the US. And I think OpenAI is within reach, I mean, geographical reach. No? And you know what they do? They go for open source model. They go for the Chinese QWQ and the QWEN model here, because it is open source and they can experiment with this, they can work with this. And now we have a methodology that is based on their insights to improve here our reasoning abilities for all other models that don't have this O1 methodology of the reasoning. So interesting that here a US university is not going here with a US company inside, but this US company, OpenAI, is so much caring about its transition to the for-profit phase. Yes, so sometimes, you know, the profit orientation is not really helpful if AI advances, and it advances here with huge steps. Okay, what are the findings for from UC Berkeley if you want to implement this on your LLM? Let's have a look at this. What they found out, they experimented quite a lot, and also with smaller models. And you might say, why 32B? This is quite huge, no? We need 8 H100 GPUs from NVIDIA. What about a 7B, a 14B? However, they said in this distillation process, they observed only modest improvement, because the complexity of the dataset they find here by QWQ has an inherent complexity level that a little 7B or a little bit bigger 14B model cannot integrate this in the reasoning process. The complexity levels are here so low, if you come with a training data set with such a high complexity, the model is not able to process this. And then they say, hey, we tried here to train here a smaller QN 2.5 14B coder instruct, and it resulted here in an increase here from 42 to 46, which was great. But however, now comes this data mixing that I told you in. By inspecting the output from the smaller models, those smaller than 32B, in general, they found they frequently generate repetitive content. So those smaller models just repeat themselves at a certain threshold, and thereby limiting their effectiveness for advanced reasoning. So their finding, UC Berkeley says, hey, smaller than 32B models? Not really. Not if you want to go for advanced reasoning. Data mixture, I told you, no? And they said, hey, we also experimented here with a lot, and we can benefit from their insight. No? They said we took then the 32B model, and then we had specific math problems from some very specific elaborated data set, and they achieved here a significant improvement in particular benchmark. For example, here in this one, they went from 16% to 43%. Great. However, when they wanted here to add a domain to math, speaking here coding, they found that this accuracy dropped to 36%. I mean, it's not bad at all, no? I mean, remember, we started at 16%, so just to drop from 43 to 36% is not bad at all. But the question was, hey, can we have a data mixture where we improve on both domains? And they now hypothesize that this decline in this performance is due to the distinct reasoning approaches required here, especially for mathematics and then for the coding tasks. So they came up with the idea we have to take into account here this particular data mixture here for our fine-tuning. And they found here a very simple solution. So the reasoning and coding often involves additional logical steps, such as simulating the test input or internally executing generated code. Whereas if you do this for the mathematical problems, they tend to be more direct and clearly structured. Well, of course, it is mathematics, no? And UC Berkeley continues to tell us to address here these differences. We enrich the training dataset with challenging mathematical problems and complex coding tasks from another particular dataset. And doing so and having a balanced data mixture now, just by trial and error, this now enabled their new model to excel in both domains, restoring here better accuracy while also improving its coding capabilities. So you see, whatever your domain you are building your LLM, be careful if you need math, coding, physics, chemistry, or whatever else, finance, you have to be careful that the data mixture is right from this high level chain of thought reasoning subchains that you are really able to get the best performance out of your LLM. Let's look at the benchmark data. So here we have this new model, this Sky-T1 32B preview with less than $500. They were able to build this model, and they say, okay, it was built on this base model, the Q1 2.5 32B instructed was not able to have this long form reasoning patterns. And then they compared here with the classical QWQ32B and with the O1 preview from OpenAI. Have a look at the data. You see the jump from the base model to now the fine-tuned model is nice, especially if you go from 16 to 43. So great. This even beats here the O1 preview model here in particular benchmark. But of course, it is kind of a mixed box, no? Because you see for Q1 84, now it's only 86, but the O1 preview is at 92, so a little bit way to go. However, if you look here at this benchmark from 40 to 56, you see that even the QWQ is here 56.3, so less performance, and even the O1 preview even have less performance. Hey, great, my English is excellent today. So you see, you have to be careful with your data mixture and everything, but I've chosen this in this video today to show you if you want to implement this. Yes, $450, $500, it is not easy. And it's a lot of money. But compare this to other models that cost tens of millions. So with these insights, we are able somehow, if we are willing to spend a little bit of money, or you are maybe a startup company or a little company, you see, even a little bit of money can bring you a long way if you want to improve the performance of your models. All the code, all the training data, all the tests, all the training scripts are open source. They are waiting for you to be experienced. Maybe you want to optimize the training data set for your particular domain, finance, medicine, whatever you can think of. And I think it's an excellent way to take here even the smaller, not as intelligent LLMs and bring them up here to an QWQ or O1 model. Great. This is only possible because of the open source model here from companies or startups like QWQ, where they open source their models. If we would go only with an OpenAI O1 model that does not give us this, we would not have the chance to advance here our open source LLMs. So OpenAI, I hope you finally converge with your for-profit orientation, and it would be so great if you would also provide at least some open source LLMs in the near future, because it would be a shame here to have here OpenAI completely excluded from the technology advantage here in the open source AI community. This is it for today. I hope you enjoyed it. I hope you got some new ideas. I hope you are now interested to build your own LLM with a much better reasoning capabilities. And if you want to subscribe, I see you in my next video.